Especially. So because I think a thing which for beginners is not explained at all is actually a Pandas index. And I think the index in Pandas is one of the, it's a major building block of Pandas. So it's really good to know it's there, how it works, like what you can gain from it, and stuff. So to bring everybody up to speed, I would like to just show you a little more on Pandas. Can you hear me like this? Yeah. Yeah. So we're going to run through this notebook, and I'd like to show you, just like to get everybody up to speed. So the very building, yeah?
There is translation ongoing, and we cannot hear you without microphone.
So okay, so I can, like that? Okay. All right, the very basic building block is the series. So let's just like build a series. You see, like it's very simple and easy. So we just pass in a list and we get a series back, and often overlooked because it looks just like okay, oh, it's nice for printouts, but actually this is already the index on the left side. So we did not instruct or give any index when we created the series, but actually if there's no index given, Pandas just creates it. But it's often overseen. So this is the first step into the index here. So, and as we see, Pandas is also like really smart in figuring out the right data type, because Pandas gets a lot of the power, or I think the power thing for Pandas is its NumPy arrays under the hood. So basically Pandas is really good in figuring out stuff. So if you just have one float at the very back of the series, the data type will change from integer to float. So basically one float will infect the rest, and the same applies for strings. So if there's one string, the string infects the rest, even if it's like a stringy number. Okay, also a caveat which drove me mad in the very beginning was just like if you have like integers but there are null values in between, basically Pandas or basically NumPy will fall back to a float data type and not an integer data type. So this is something you need to be aware of. Then, once we have the index, we can select where positions or slicing, as we are used to select stuff in Python. So this feels very natural and simple. So working with series is very Pythonic. And there's also a method called ilog to work to get stuff via the position in Pandas. And there's also like the log method. So, and the difference is ilog works with the position, and it's quite easy to remember if you think, okay, I is like integer, and look up something by an integer is basically look up something by a positional value, and this is basically the bridge I built earlier days in my brain. Okay, but it's not just like the position, we can also select stuff via labels. So in the first line here, I am just like resetting the index to alphabetical values. So our series now, as you see on the left side, there's no longer, the numbers are gone, so we have A to J here, and we can just use it as we would use like a dictionary in Python, and check for a C, or yeah, and also use the log method and pass in C and get one value back. One nice thing is actually we can also slice by labels. The only difference to positions is, since it's an explicit label, the label is inclusive, because of course positions as in Pythonic, the last number is excluded. And still, though we do have text labels now for our data, we still can use integers, and Pandas will fall back to using it by position. So far so good. I think this looks, yeah, that's easy. I guess we can also use non-unique indexes. So for example, here I'm resetting a new labels, the labels to Gattaca X, Y, Z. Still we can use the log method and get something useful back. But as we see, once the index is no longer unique, Pandas is really smart and tries to figure stuff out for you a lot. As Pedro explained earlier, Pandas is super cool in being smart, but it can be also like a problem if you start with Pandas, because you really rely on stuff just works and until it suddenly doesn't, and you're not aware why. So, but for example here, if we try to slice by x to z, which is unique in our index, it still works. So, yeah. So, a good way to figure out how the index is actually built, because this is a tiny data set, we can just print to our screen, but imagine we have millions of rows. A good thing is to actually check and inspect the index by just with the is monothonic attribute. And this is bookkeeping, it's an attribute, so there's no overhead asking for it. And you can also check if it's unique, and if I reset our index to something unique with a range, we get this back, what we had in the earlier beginning, and we ask, okay, is it unique? It's monothonic, and it's also monothonic increasing, so you can get some nice insights into your data frames. So, on building blocks in Pandas, so we learned already, we have NumPy arrays. NumPy arrays are typed, and this is where the performance comes from. It's no longer dynamically typed or strongly typed. Python is strongly typed. We can basically, it's a NumPy array, a typed array with labels. That's a series, and that's actually a concept which was borrowed from the R language. And the other thing is like a data frame, which is a two-dimensional structure, or what we could refer to as a table. It's basically just like a number of series, and they all use the same index. And one thing to learn is, especially if you're coming from a programmer, I'm more like I came more from a programmer than from the analytics side to Pandas, so I like to think in loops or like comprehensions. And so it's row by row, but yeah, in Pandas we have to think differently because it's more like in vertical data and thinking in series, so basically thinking like 90 degrees turned. There's also a three-dimensional structure in Pandas. It's called panel, but it just has been deprecated in the Pandas 0.2 version. Fun fact is actually the pan in Pandas came from panels, so half of the name is deprecated now. The reason is hardly people did not really use it. So, and you can basically do the same with the MultiIndex, which I'm going to introduce you later to. So, okay, so far so good. Let's we saw some nice animations now. Let's get to the data and return to our notebook. So let's read in a data frame I have stored as a JSON file. So it's like a simple data frame. It's 10 by 10. And we can now, and this is something really easy to remember and learn, if we have a data frame, we no longer, we select the column or the series when we ask for just like a positional value like here too. And just like for the next steps in the presentation, only worry about, oh, sorry, you don't see what I'm doing. Why? Sorry. Oops. Nobody's complaining. Sorry for that. So let's go back. This is what is this guy talking about? I'm talking about this. Yeah, so this is the 10 by 10 data frame, which is just like positional values here. And just like for the next steps, just ignore the first line, and because this is just like for highlighting the rows, for make it a little bit more readable. So I'll just look at the last line, because this is where actually stuff is happening. So if we just ask for 2, we no longer get the row back, we basically get the series back. And I think, okay, yeah, it's a data frame, so that's something we can remember and adapt. But something that drove me really mad in the beginning, let's make a little more space here, was the slicing. Yeah, because once you slice a data frame, we're actually slicing the rows and not the columns. And this is, there are good reasons for this, but it's not very, yeah, it feels weird, and especially, and we all admit it, you go Google for a problem, you end up looking at Stack Overflow, you see some attractive code and just like try it, and then you see, hey, why isn't it working? In some other context, it was working. And there are some breaks, and I think the best thing is to get a deeper understanding on the how indexes work and the selection works. So for example, here on DataFrames, we also have an ilog method, and we can just like select in a very Pythonic way. So we can pass actually on the data frame, we can pass in 2 values in the ilog method. And if you don't see it right, actually the ilog method uses parentheses, uses square brackets, not parentheses. It's like a function, but we have square brackets to call it because actually it uses the getter and the setter on Python. And it's like in a dictionary, getter and setter is square brackets. That's why the ilog method also uses square brackets. So it's basically once you know, okay, ilog on a data frame accepts 2 input parameters. It's very simple because it's just like x and y, which is usually referred in pandas as x's 0 and 1, which drove me mad as well, because what's this axis stuff all about in pandas, I thought? Because pandas, the default values of pandas are usually set very good. So usually you don't have to think about axis to use pandas. Most of the times the default parameters are set and work. But then you stumble across, no, you have to use the other axis. What's axis? And basically it's very simple to remember. So the 0 axis is the horizontal, and the axis 1 is actually like the vertical, and I'm standing up for this because I'm vertical, and it's easy to remember because axis 1 is just like this, like a 1. So this something to remember. Or you can also like say it's like xy coordinates. Okay, so far so good. So how can we select a column with the ilog method on a data frame? Actually, oops, I'm sorry. It's quite simple. We just put in double dots, and double dots is select or copy everything in like as we do in a Python list, and just pass in the values for the slice for the columns 2 and 3. So it's basically, once we've seen it, it's quite a simple concept. All right, let's do the same and go back to our data frame, and let's rename the columns and rename the index into labels. And just like as a short demonstration, we can use the same here for, so this is how our new data frame looks now. We can select a column by name now, which is, I think, expected. We can still slice and use alphabetical row labels to get the rows back. And we can also just like slice columns by passing in the columns slice we are looking for as a second parameter. And this is optional. It's on the log method, we can just pass in the first one, so it will use the rows, but at the second one, it always uses the columns, but that's optional. Okay. And of course, we can also use it for a segment. So I think this was quite expected, and I hope you now have a better understanding on how useful the Pandas indexes are and how to choose the stuff. And if you're new to Pandas, I know just using the square brackets, it looks more fancy, but actually if you're a beginner, I really recommend to use the log and the imlog methods. It's more explicit, it's totally okay. It makes your stuff more readable. And okay, so let's move on to the next. So actually I have some fake generated sales data, and the sales data is from the Bluth online store. And who knows the Bluth family? Okay. Yeah, so it happens in Germany all the time. Nobody knows Arrested Development, which is a really fun TV show. So yeah, you see Catherine, she has a lot of fun, I'm just mentioning it. So, okay, the Bluth online store sells stuff, but they only sell the 10 most sold products of all times. So this is the Rubik's Cube, it's a Toyota Corolla, it's an iPhone. But this is basically the joke. If you know Arrested Development, end, you have like the mother, and she's like only has her Mexican servants, and she never leaves home, and so she's talking to her son Michael, and she says, "Hi Michael, how much can a banana be? Like $10?" So she's never been to a supermarket basically, and yeah, so they sell like these 10 products and bananas for $10. Okay, so let's look at our data set. So we just peek into our data set, and if you read in the data, I think it's a very good practice always to inspect it with the info method. So we already see, this is why I also like probably a little hint in the file name, it's clean data. So basically Pandas is able to figure out all the data types. So we have 2 date times, integer and float, so and all the other stuff, the objects are text, and this is yeah. So this is cool. So we don't need to mangle we don't need to mangle the data types to have something. And let's do something with what we call the Boolean index. And the Boolean index, we can just like create one. So basically, I'm just pulling the units here. So I'm just asking for the units date series, and I'm just like pass in greater 40, and I get just like true and false values back. So it does not directly select the values from the series. It just says, okay, I still have the same length. The structure is maintained, and it's just like, yeah, true or false. And if we pass in this Boolean index, or what's often referred to as mask, we can just pass it on and select stuff from our data frame, and then we get everything back. Where in the units row we have more than 40 units sold. Yeah. We can also combine the two with an ampersand, so subtle difference here is you have to use parentheses on the 2 stub segments, and so it's really easy to do an AND comparison or with pipe an OR comparison. Basically, you can get something true or false back, apply it to the data frame and the data structure, and get stuff back where the value is true. And I think this is also like a very great concept in Pandas, and it's a lot of fun to use. Okay, next, something else which drove me totally mad in the beginning. I'm used to work with databases, and so I was very familiar with, okay, I just do a group by and I get the data back. And I used to do the same in Pandas, and I just did a group by, and then I really had a hard time in the beginning. How do I select the data? I got, basically, I just grouped. I just want to access them, and it felt not really natural because I was not aware actually the grouping returns a multi-index. So what's a multi-index? So let's create some new data set, and imagine this is just like, it could be hotels in a city, and they have a price and a rating and a category, and their cities are also like in a country. And if we do a grouping here, so let's do a group by country, city, and category, and just like check what's the mean price, for example, or the mean rating. So if we do a group by and apply a mean, sum, average, or whatever on it, Pandas is always already that smart, only working on numerical values. And basically, this is what we get back here. It's like, okay, we see, okay, this is like in Germany, Berlin, Mannheim. You don't know probably Mannheim, but it's my hometown. That's why I sneaked it in here. And we have all these data here. And then, and this is also like just like, basically, I can say like nicely displayed. If you don't like it, you can also like turn it off if you want to. So you can turn off the sparse display in Pandas just as a tip if you want. But actually, I do like the sparse display, so I turn it back on again. And now, how can I access the data? And I think one very easy way to understand how to access the data is actually to have a look at the index again. Because what do we got back as index? We get a multi-index back, and we already see, okay, oh, multi-index has levels. Levels are the countries, second level, second list is the cities, the third levels is the category. Oh yeah, there's also this. Okay, that looks like actually quite understandable. It's basically just like a nested structure. We can also ask index levels here. So, and we see, okay, the index levels are actually like a frozen list. Again, this looks very familiar to what we expect. And although we have this new structure, still the names are still maintained from. And then we can also like just ask for values from a certain level. So what's on the third level? So 0 indexed here as well. Third level is 2. Oh, we see, okay, that's the categories, and we get just like an index back. And we can also ask, well, what's on the first level? And we get the second level, sorry, and we get the second, the cities back. What we already see, they're mentioned more than once here, because like, yeah, it's someone. And basically, it's also like really easy to select data from a multi-index. We can also just use the log method and ask for, okay, this is the data from Germany. We can basically pass in a tuple and see, okay, what's the data in Mannheim. Basically, it's just like we pass in tuples and walk down a path to select data from a multi-index. And another nice feature is actually we can also ask for a maximum value for if we do a sub-selection on our multi-index, we can ask, okay, what's the maximum price or rating for the series actually. I'm sorry, this is a bad example, you have to believe me here. I have not noticed before, sorry, yeah, but yeah, actually it's giving you the maximum value on the columns back, so it's not just like on the same line. Yeah, of course, why is this not working? Okay, let's skip that. Because, why, what's going on? Okay, I'm sorry, okay. Oh, there's no free, why did I pass it in here? Okay, why? Strange bug, I've done this talk before, so let's just take. Oh yeah, okay, this is where, okay, there's no category 3 in Mannheim. There used to be one, I don't know, it disappeared. Okay, sorry for that. So we see, so if we walk down up to the very bottom, so we have grouped by 3 attributes, and we now walk down 3 basically steps down the path. It's very simple. You get immediately a series back. So, and that's basically all. Yeah. What I used to do in the beginning, and it's still handy, if you have a multi-index, to unstack it. So what's unstacking? So if we unstack something, we just like take the lowest level from our grouping and basically make it a column. So we move it up, and we can also like unstack it even further and just really flatten it out. It can be useful if you want to pass it on to another API or data structure to just like unstack stuff, and of course probably deal with the NaN values we have here. So my favorite is the datetime index actually. So this is a data set. It's just like from the sensor, and it has just like a timestamp and a temperature in Celsius. So, and if we plot it, we see, okay, this is how it looks like. If we look what's inside, we see the timestamp is still an object. Thank you. It's still an object, so we have to probably convert it. If you look at the index, we just have like positional index. It's just the range. So let's change that. So in this next line, I'm using the pandas to datetime method, pass in the string from the timestamp, and pandas is pretty good in parsing timestamps, and we reset the index to a timestamp. So let's see what we have here. Now we have the timestamp still in the series where we imported it, but we see there's no longer positional values here. It's a timestamp now, and I think this is such an awesome structure here. So if we look at it, we see it's actually timestamps. We can check, it's not monophonic, but it's unique, so probably it's data from one sensor only. And if we plot it, Pandas is also like really smart, saying, oh, okay, so date time data is basic ordinal, so basic also like plotted in an ordinal fashion. So there's no sorting, nothing involved. Just like by changing the index, we now see something more, which is like looking like, okay, this is like how temperature behaves, and we already have the timestamps on the x-axis without doing anything. And what else can we do? We can also just like do a grouping and now use the index.year, because the index is now datetime, and we can just access attributes with the dot notation. So we can just simply ask for the year and the week, and then group it by both, and get them in a plot bar. So a good use case is, okay, management wants to have a weekly, monthly report, and another approach would be to add extra columns with year and month, and do some calculations. But actually, once you have a timestamp, datetime index, there's no need for that. You can immediately ask for the values and group by, and without adding extra stuff. We can do the same for the day of the year. And another nice thing on the side is the ACK method. The ACK method, you can just like chain it to a grouping and pass in a list of values. So it's really easy to get the minimum and minimum maximum values for each day, and just like plot them in the one-liner, just like as a side note. But like the biggest question usually is, the weather on the weekdays when we have to work is usually so much better than on the off time on the weekends. So can we find out? And actually it's really easy to find out. So in the first line, actually here we are, I'm adding two new series. One is called weekday and the other is weekend, and it's just like a true-false value. And in the first, I'm just asking for the weekday, which I can immediately ask the datetime object for. So we get values back from 0 to 6. Little hinter, usually a pandas datetime parsing is often very US date friendly. US date month first, only country in the world. But this is basically Monday first. So this is like really standard, national standard. And then it's quite simple. So we have these new two columns. We know, okay, this is a measurement from a weekday and the other is from a weekend. And we just can just like plot how the temperature behaves during the day. And actually, like in our data set, it's getting warmer on the weekends earlier. So yeah, just feels different when you have to work or off. Another nice feature is we can also select ranges by passing in a date range, but just like as strings. So we can just like select, for example, like 2 days here and plot the Celsius. And also the daytime goes really down to the seconds. So for example, here it's just like simple to do just like a plot of the temperature between 12 and 4 o'clock in the afternoon. So it's just also like a Boolean index combination, which we've seen before with the ampersand. So this is like super cool. And this is not just everything yet, because once we have a daytime index, we can resample. So we can just like resample our data by day. So there's no need to do some sums and comparison. Thank you. We can just resample by day. We can resample by month. We can even come up with our own resampling. So if you have the feeling to resample your data by 3 days, you can just pass in 3D and just like plot it. And of course, also resampling works also, is really nice if you change, for example, with ACK, min-max. You have your data resampled by day and can immediately plot minimum and maximums of that day to the screen. Since Pandas was originally developed at a hedge fund, you have a lot of resampling options. And I've taken the freedom to put the ones for humans on the left side, and for the people working at hedge funds and bank are on the right side. I think it's any measurement or grouping we can think of, like, yeah, you know, like a quarter start frequency and all this stuff. So basically there's anything there. And as last, also like really handy, often unknown, is the categorical actually. So let's go back to our Booth store and let's have a look at the data. So here we see we have like 1,000 rows, and yeah, well, it doesn't look that bad, but actually we see, okay, what's this plus sign actually here? And I have to work there because we have to see it. There's like memory 54.8 plus. What's the plus? It's often overseen. So actually the plus, so if we use the info method, Pandas is only giving us back the memory which is used, But in this case, for objects, because text is stored as an object, it only counts the memory used for the references to these objects in memory. So let's have a deeper look with the memory usage. And say, okay, looks still pretty good. But if we look again on the memory usage and pass in like deep true, and deep true is basically instruction, okay, what are you really using, Pandas? And we see, oh, okay, as expected, basically, name, customer, all the text stuff is, of course, needs more memory than numerical values. Okay, what can we do about it? We can actually use the S-type method, and it also accepts the dictionary. And now, and the dictionaries are the three columns with text data, and I'm asking just like, okay, make them all a category. So let's convert them to a categorical, and we have a look into this in a minute, and see how the memory usage actually has changed. And let's do the calculations. So we see on the numerical as expected, it did not change. We have more than 50% less memory used on the name. And actually on the product, since we only sell 10 products, basically the memory usage has dropped by 97%. So that's a lot. Thank you. So let's do the math. Okay, in total we save about 60% on memory, just like converting it into the magic categorical. And if you basically if you work a lot with SQL databases, actually it's a very simple concept, because actually categorical just like takes all the text data and basically builds a lookup table. So this is something you would do in an SQL database anyway. Let's build a new categorical here. So basically now we still see the representations of the text if we plot it to the screen, but in the background it's basically IDs and references to a lookup table. So of course it's a very simple concept to save a lot of data. And another nice feature is categorical can also be ordered. Let's make a new example here. So I'm just creating a categorical. And the values of the categoricals are just the values bad, neutral, nice, good, and excellent. And then the second line is I'm just giving them an ordering, because like bad, it's from bad to excellent. So excellent is the best. So, and if I'm asking for the maximum value, it's excellent. If I'm asking for the minimum value, it's bad. For example, like a good use case is if you have like, imagine having data from a survey where people can choose, oh, this is bad, this is good, excellent, or something. It's a really nice way to reorganize the data, not just like to save the text. You can also like do other nice stuff for it. So let's go back to the blue store, because my favorites actually in the blue store is actually the Rubik's Cube. I like Harry Potter books. The Corolla is, I think, a mistake, but you see where I'm heading. So I'm not really into bananas. So let's define the favorites here. So I've put them more in the ranking what I like most to what I like less, and but to make it a little bit more accessible, actually this list is reversed at the very end. So favorites look like this now, and I'm applying the categorical to our sales and rewriting our sales data column. And then we can do stuff like, for example, hey, give me everything back from the sales data, which is at least as good Harry Potter books. And this is what we get. We get the Rubik's Cube and sales data for the cubics. And of course, you can also like use it in a survey in ESEC, say, give me everything back from the survey where people replied greater than good or something like that. I think this is it. Or I'm basically finished. 33 seconds left. No, I'm done. Thanks very much for your attention. I hope I provided some useful insights into Pandas for you. Yeah, thank you.
Thank you. Questions? Come on, guys. Questions?
Seems I have answered all questions.
Here you go.
This is mostly like rhetorical questions. Do you like this interface of square brackets, and when you actually select actual column again to make select to this column, like the sales data, again, you make then comparison and then actually gives you the mask and that you apply again to your data frame. So you basically, if you want to select something from one column, you mention your data frame at least 3 times.
Yeah.
What do you think about this?
I like it. I like it a lot, but it took me some time to get used to it because naturally it feels a little bit redundant, but actually it isn't. It's just like probably more nested than stuff we could probably also like chain or like get subsets. So yeah, I share the feeling. It feels redundant, but actually once you get used to it, and I mean like it's something, if you use something like a lot, you get used to anything. So probably I'm not a little screwed already. Yeah.
Yeah, I almost passed this frustration, but yes.
Yeah. So yeah, but actually I think it's a good concept once you see it's basic nesting. So get something where something is basically true and right for the data you look for, and you just pass it on to the data frame again. I mean, like, what would be the other option? Like, use a method and basically pass it on as a parameter or something like that, or 2 parameters or something else.
Yeah.
What are the possible alternatives we can? Because we can basically make pull requests to make the Pandas API even larger.
Yeah. Thank you. Very interesting.
Could you say something about index performance of Pandas? By my opinion, it's more effective sometimes use databases to this to make groups and something like this. Maybe you have some recommendation to use Pandas and DBs.
Actually, my main recommendation is always like try to stay as close to the data as possible. So, so if you have data in a database anyway, which has like a good query or aggregation framework, use it from the database if it's not too complicated to build the aggregations, and basically probably use something pre-aggregated data in Pandas then. I think that's for nowadays, I think moving data is the most expensive thing we have in the system, because we don't really have to worry about RAM anymore or hard drives, and networks also. Yeah, network is like the main bottleneck nowadays, probably depending on the data set. Otherwise, if it depends a lot on the size. So rule of thumb is like Pandas uses 5 times the memory which we have on disk. Just like as a rule of thumb, it depends a lot on the data, it's if it's a smaller data set, there's nothing to worry about and nothing much to gain. But I think if you really want to have a deeper understanding on did you attend Pedro's talk earlier?
No,
So
I skipped
watch
this.
the video, because I think he did an awesome job on explaining all the pandas and indexes and timings and caveats. So watch the video. I think he did. I cannot do it better now, and even though I only have 2 minutes left.
Okay, thank you.
More questions? No? Thank you.
Yeah, thank you.